the energy for beams under pure bending. Again, the U equal to the volume integral and QE sigma square dV. And this one, what is sigma? For being under pure bending, for this case, we know the sigma equal to minus ny divided by I, right?
Well, so we have to think of the, well, we don't necessarily have to think of the direction, do we? Because it's going to be squared in the end.
Yes.
So we can just assume.
Yeah, just take the magnitude. So we put it in here. So see what happens. Q, E, I square, and M square, Y square. Okay.
Would you use Y or X, or does it not matter?
Here we use Y.
Okay.
Do I have? So how about this? Let me. So if this is the beam, okay, and again the bending applied on the plane of symmetry, and so this is our x-axis, and this is our y-axis. So those notation simply follow this one. So this is the terms in here, and now I want to do a little bit tailor the integration here. So volume integral basically is equivalent to the area integral, and this is the length integral from 0 to L. Okay, so here is L. So here is dA dx. And again, because here we talk about is, you can see, let me pick up one cross section here. And this is our neutral axis. And we know that the distribution of the normal stress on the cross section is not uniform. So that means the distribution of the normal stress, let me say that should be, say on this side, the normal stress should be, distribution should be like this. Right? So that means if we want to integrate, then we have to integrate the area straight by straight. So which means at this level, we think about this is our dA. Okay, because, and one more time, because the distribution of the normal stress on the cross section is not uniform. So we have to deal with the dA and adding the small force layer by layer. Compared to this case, because the normal stress is uniform everywhere, so when we split the integrations, I will be able to use the whole area to multiply that constant normal stress, but not this case anymore. So that reason we take the dA and we integrate over the whole cross section. So that means we add up the layer by layer. Okay, so that's the reason why here. And so now we'll let us integrate the whole things here. So let me keep writing to you here. So now let me continue to write up here. So from these equations, and let me arrange the contents here to see how much we can integrate. We can simplify. So that is m squared and 2ei squared. And I'm going to group the y squared dA together and dx. Okay? And usually from here you can see m/ei squared, those terms are constant with respect to any cross section. So we might take out q here. We might take out the m squared qei squared out of the area integral. Okay? And this term actually is how much? This term equal to I. So we can simplify. You can see from here the area integral of this term equal to a constant of a moment inertia. So we can simplify into here. 0 to L m squared q e I squared cancel with I. So we leave one I here. So basically here for our strain energy, and again we have very nice line integral, and that simplify our work a lot. Okay, and again the I is the moment of inertia, and for our constant, the uniform beam, the I should be constant, and along the whole axial direction. E depends on the homogeneous or not. But in general, we just simply leave that inside there. Okay.
Wait, how does that equal I again? Like,
This one?
yeah,
Yeah, this one equals to I.
that's just the definition.
That is not definition. That is, I think so. Yes. This is I, and here again, I is the moment of inertia respect to the neutral axis. Okay. Moment.
No, yeah, I understand what I represents. It's just
Yeah. Respect to the neutral axis. This is important. It's not to anywhere, but to this one. So under this case, per our corner systems, that one equals to I here. And so we done this one. So probably today we exercise on the normal on strain energy due to the normal stress, normal strain, and probably next time we will do this one. So here yes.
So in this case, when you're looking at just, is there anything that you can pull out other than the two? Because like if E is
Yes, yeah, if you like, you can put out two here.
But is there anything else that you can pull out? Like, can you? Would you be able to pull out the like?
We can use examples to show you. Okay, so that's in the next page here.